This video is an introduction to the concept of forces. In this video, we have two main ideas that we're going to discuss. The first idea is that force causes acceleration. And the second idea is that the net force is the vector sum of all forces acting on an object. To get us started, I want you to think about what you do when you exert force. So for instance, what do you have to do to exert a force on your physics textbook? And you'll find that whether it's a textbook or a volleyball or a person, there's really only two ways that you can exert a force on an object. And that's that you're either going to push the object or you're going to pull the object. And that's the definition of a force. A force is simply a push or a pull. Let's think about, what does that force accomplish? What happens to a ball if you exert force on it? So let's say the ball was at rest. What happens after you put a force on it? Well, the ball that was at rest is now going to move. So in essence, we're saying that the ball, which had a velocity of 0, now has some velocity. And since all we've done is change velocity, we can call that acceleration. So a push or a pull caused a change in velocity, or another way we can say that is that a force caused and causes acceleration. But can you think of an example or a situation in which a force would not cause acceleration or wouldn't cause a change in velocity? What happens in an evenly matched game of tug of war? Nothing, right? The rope doesn't move even though both sides are tugging. But what about if one side is the entire football team and then I'm standing on the other side? What happens to the rope? Well, obviously the rope moves in that case. So what we really mean to say is that if all the forces acting on an object don't cancel out, then an object will accelerate. When forces don't cancel out, we just say that there is a net force there. And all that a net force is the vector sum of the forces acting on an object. Which really just means that both direction and magnitude of the forces matter. So if a large rightward force is placed on an object, while a small leftward force is also placed on the object, how is the object going to move? Well, the object moves to the right because that's the direction of the larger force. But in that case, some of the rightward force was actually canceled out by the smaller force because the forces were in opposite directions. If both forces were in the same direction, it's going to cause the object is still going to move to the right, but in essence, the forces that are going in the same direction would really just be added to each other. So if you're confused about this idea of forces canceling out, think about our situation of tug of war, where they're evenly matched. So when they're evenly matched, it's not moving, right? And the reason why the rope isn't moving is, like I said, because both sides are pulling with the same amount of force, but their directions are in the opposite direction. So when forces are equal in magnitude or size, but in opposite direction, there's no net force. But what happens if one side all of a sudden just lets go? Well, if you've ever seen this, it might be funny to watch because the side that didn't let go just falls over, right? They just fall down. And it's not because this team that let go put an extra force or pushed harder on the people who were pulling to cause them to fall over, but all that happened is they let go. And so in their letting go, there was now only one force being exerted on the rope, and that was from the team that was pulling. So again, all of this illustrates that force causes acceleration. So in conclusion, a force is merely a push or a pull that causes acceleration. However, if more than one force is acting on an object, the object accelerates if and only if there is a net force, and then the object will accelerate in that direction.